Hi guys, in this video we will study what is stars and bars and how can it help us to calculate number of ways to place n indistinguishable balls into k labeled bins. So assume these are stars and assume these two are bars. With two bars, how many partitions we create? We can create three partitions, right? First partition is this, second partition is this, and third partition is this. So to create n partitions, we need n minus 1 bars. And to create k partitions, we need k minus 1 bars. So suppose we want to calculate the number of ways in which we have to distribute 5 stars among 3 people. Obviously partitions or people are distinguishable, so we need 2 bars, and what we can do is by brute forcing we can keep these pens like this and calculate the number of partitions. Okay, so suppose I kept these pens here. This means that the first person is getting all the 5 stars, second person is getting no stars, and third person is also getting no stars. But this brute force approach will take a lot of time, right? So is there any formula to do such thing? There exists a formula, this, and in this formula n is the number of stars, k is the number of people or partitions or bins, and k minus 1 is obviously the number of bars, right? If I keep these 2 pens here, then how many objects are there on the table? How many different objects are there on the table? There are 5 stars and there are 2 bars, right? Total 7. And if I want to know how many ways there exist to place these 2 bars in their respective positions, then it will be, there are 7 places, right? And from 7 places we need 2 places for 2 bars to place. So it will be n plus k minus 1, which is 5 plus, I'll keep this here. In our example, n is equal to 5 number of stars, k, which is number of partitions or people, are 3. So number of bars is 3 minus 1, 2, right? So out of 7 positions, 5 of stars and 2 of bars, we need to select 2 positions to keep our bars among those 7 positions. Or we can also say that among the 7 objects, we need 5 positions to keep our stars, right? Both are same. Exactly, like both are same. These two formulas are exactly same. In one formula, we are choosing places for stars which are n, and there are n stars, and in this formula we are just choosing bars. For k partitions, there are k minus 1 bars. I hope you are with me. So let's solve a question in which a plus b plus c plus d is equal to 12, and we need to calculate the number of non-negative integral solutions, right? How many ways a, b, c, d can have value which will add up to 12. This is this easy question. If you try to solve without any formula, it will take hell lot of time. You have to use brute force approach, which is not feasible. So we'll choose stars and bars. Yes, we can choose stars and bars because numbers cannot be distinguished, right? 1 plus 1 plus 1 plus 1, it's a number, right? And these are distinguishable variables, a, b, c, d. So number of n is equal to 12, k is equal to 4. So our formula is, we have total number of objects are 12 plus 4 minus 1 on the table, right? And among those we need to choose the number of ways to place 3 bars because there are 4 people. So it will be 15 choose 3, right? This is the answer, 15 choose 3. Okay, we can solve another question. How many ways are there to distribute 10 chocolates among 3 girls in which the chocolates are indistinguishable? You cannot distinguish between chocolates, but you have to distribute between 3 girls in which every girl must get a chocolate. So we need to calculate the number of ways to distribute 10 chocolates among 3 girls in which every girl must get a chocolate. I mean, at least one chocolate must be given to a girl. So in that case, consider 3 girls and we have 10 chocolates. So every girl must get, or each girl must get a chocolate. So we have to give out of those 10, initially we just need to give this chocolate, the 3 chocolates to them. Okay, so we are left with 7 chocolates. Let's name this girl A, this girl B, and this girl C. Then A plus B plus C is equal to 7. Using stars and bars, for 3 girls we need 2 bars. Okay, so N is equal to 7, K is equal to 3, and 7 plus 2 choose 2 is equal to 9 choose 2. This is the answer. In which you need to calculate the number of ways to distribute 10 chocolates among 3 girls in which each girl must get at least one chocolate.